All right, Algebra 1B students, welcome to part 2 of lesson 11.5 on solving rational equations. In today's video, I'm going to show you a pretty common word problem that exists out there that we can use rational equations to solve quite easily, actually. And then I'll show you a slightly different type of rational equation where we are going to solve by cross multiplication instead of by canceling our fractions. So to begin, we're going to start with a work problem where we have two people doing a job in a certain amount of time, and then they're going to work together and see how long it'll take them to do it together. So it's not necessarily as simple as it sounds, but it is still relatively easy to solve. So here's our problem. It says Amy can paint a loft apartment in 7 hours. Jeremy can paint a loft apartment of the same size in 9 hours. If they work together, how long will it take them to paint a loft apartment of exactly the same size? Now, it's not just 2 hours. It's certainly not 16 hours. Because we have to think of this problem in terms of how much apartment each one can paint in 1 hour. Okay? So we relate the fraction of a loft that Amy can paint in 1 hour with the fraction of a loft that Jeremy can paint in 1 hour with the fraction of the loft that they can together paint in 1 hour. Okay? So we're going to say that T is the amount of time it takes them to work together. We don't know what it is yet, but we know that in T hours, these two can paint a loft apartment together. Okay? I know that Amy can paint one in 7 hours, which means every hour she gets 1/7 of the project done, because it takes her 7 hours to get the whole thing done. So she gets 1/7 of the project done in an hour. Jeremy, of course, would get 1/9 of his apartment done every hour, because it takes him 9 hours to complete that project. When I combine those two rates of painting, how much of the apartment they're getting painted in 1 hour, that needs to be how much of an apartment they can paint working together. Now, I don't exactly know what that is, but I do know that if it takes them T hours together to paint the entire apartment, then in 1 hour they must be able to get 1/T of the apartment completed, because if you do that T times, you'll have T/T, and then you will just have one whole apartment done. So we are always relating the hours, and we're just making fractions out of it. 1/7 of an apartment every hour, 1/9 of an apartment every hour, 1/T of an apartment every hour when they work together. Now that is a rational equation that we can solve. 1/7 plus 1/9 equals 1/T. So I'm going to solve this by getting rid of all my fractions, multiplying by the least common denominator, which in this case, 7 and 9, I think the only thing I can get there is 63, and then I'll need a T as well. So I will multiply all of this by 63T. 63T over 1. And I end up with 63T over 7 plus 63T over 9 is equal to 63T over T. Now I can cancel a lot of things out here. The 63 can become a 9 and the 7 will go away. Here the 63 will become a 9 and the 9 will go away. So I end up with this becomes a 7. 9T plus 7T equals, and then here 63T and T, the T's go away, and I just have 63. So if I combine the 9T and the 7T, that's 16T is equal to 63. Dividing by 16 gives me that together it will take them a grand total of 63 over 16 hours. that we could easily turn into a decimal by just doing a division problem. 63 divided by 16 gives me about 3.9 hours. Okay, so there's a rational expression problem that, like I said, is quite common on standardized tests and things like that. So just remember to think of it as fractions of the apartment that they're finishing in 1 hour. All right, if you have questions about that type of problem, you can feel free to ask me in class tomorrow. We're going to go on and look at one other type of rational equation that we can solve. And this is one that does not actually involve two rational expressions being added or subtracted on the same side of the equal sign. It's just one rational expression equal to another rational expression. For example, 4 over x plus 2 equals 3 over x plus 1. So he wants to find the solutions there. And this really is a proportion, right? It's two fractions that are equal to each other. And hopefully we remember from doing proportions quite a while ago that when we have two proportions set up, we do what is called cross-multiplying in order to solve here. So as long as it's just one rational expression equal to another one, nothing added or subtracted onto those fractions, we can solve by cross-multiplying. So I'll multiply 4 on the top left by x plus 1 on the bottom right, and then I'll multiply 3 on the top right by x plus 2 on the bottom left. The distributive property gives me 4x plus 4 is equal to 3x plus 6. I'll subtract 3x and subtract 4. And I will get that x equals 2. X equals 2. And obviously I should plug that back in here, check it out, and make sure that it works. Well, 4 over 2 plus 2 is equal to 3 over 2 plus 1. Is that true? Well, 4 over 2 plus 2, that's 4 over 4 equals 3 over 3. Yep, that's true. I'm good. Okay. So here we're just cross-multiplying right away, which gets rid of our fractions, just like our fraction busting, our common denominator multiplying did. Now we're just getting rid of our fractions by cross-multiplying. I would like you to try that here with both letter A and B. These two rational equations where we just have a rational expression equal to another. So pause the video, take a look here at letter A and B, find me the solutions, make sure you check them, because I promise in your practice problems tomorrow, some of them will be extraneous, even if they are not here. So make sure you check your answers, but pause the video, take a look at these two problems, find me the solutions, then come on back and I'll show you what we should get. Okay, letter A becomes 3b minus 6 equals 5b plus 10. B ends up equaling 2. Just kidding, B ends up equaling 8. Oh. Let's see. Minus 3b, minus 3b, minus 10, minus 10. Negative 16 is equal to 2b. B is equal to negative 8. Negative 8. And then over here, we actually get a c squared involved. Minus 4c equals 21. Which means c squared minus 4c minus 21 is equal to 0. Now I'll solve by factoring. C minus 7, c plus 3 equals 0. So c is equal to 7, and c is equal to negative 3. There I get two answers, and I should check them both. If you have questions about solving rational equations by cross-multiplying, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you tonight. Have a wonderful night.